One of the beautiful things about observing the Earth from space is that space doesn't know any borders. These satellites are orbiting around the globe every 90 minutes. They're going around the globe, constantly on, constantly capturing images. It's all about how do you make sense of all this data that's being collected. We only have one planet, and it's constantly being strained for its natural resources, for human and political strife, for security applications. There's constant change around the planet, and it's really important for us to have a catalog of this. We call it our time machine into the planet, where with our sensors always on, we're able to basically have a history going back in time to 1999, which is quite a ways now. It's about 18-year-old collection of data. It's fundamentally consistent throughout the globe. And this allows us now to compare regions over time, to compare the effects of the environment, of security situations, and of people around the globe. One is cloud computing, the available of cheap compute and storage. Number two is the advancements in deep learning and convolutional neural nets. What this allows us to now do is very reliably parse through all of that data. And then finally is the model training. So we believe at Digital Globe that crowdsourcing is actually a way to scale these training of machines. We're seeing a lot of opportunity for these data sets. The traditional market for satellite imaging is for defense, for security. Knowing what's going on around the world, where threats might be coming. For environmental monitoring, a lot of companies are interested in getting environmental benchmarks, but also tracking across time the environmental conditions of where they operate. And then finally, actually, one of the most exciting things is high definition mapping of the built environment. So we're seeing a lot of opportunity for self-driving cars, for drone navigation, for being able to allow these new technologies to operate with the built environment. In Africa, we were deployed to help reduce the prevalence of malaria. And malaria, as we know, is correlated with standing water, being able to identify areas of standing water, and the people that live around it and reduce their exposure to it has had a meaningful effect on reducing the impact and widespreadness of malaria. We had a pretty big deployment around the Ebola outbreak last year, where some of the most affected regions were actually the more rural regions, the more poor communities in Africa. And these are areas that aren't necessarily mapped. So we actually collaborated with the humanitarian OpenStreetMap team, used our satellite imagery in order to create objective maps of where populations reside, to make sure that they had access to the health care that could not only help the individuals, but also reduce the spread of the disease. We have an ongoing engagement with Facebook, who's looking to detect where populations are so they can connect them better. So you hear about internet for everyone. They need to know where everyone is if you're gonna have internet for everyone. And it turns out, it's actually kind of a shame that in 2017, we still don't know where a large part of the population of the world lives. We should be ashamed of ourselves, and we're looking to change that.